Right, this seems to be working. G'day internet. Let's see if we can shoot this in one. So, I'm starting a new project, which I will be video blogging, as I've told many friends, and people who usually watch my stuff. If you're a person just coming across this, me talking with this lovely background, I'm Sampey, and I don't know, I build stuff and I make stuff. I'm going to do a micro home, and we're going to blog the construction process because I think it's really important to get the knowledge out there on how to do this stuff. This seems pretty bargain basement for me, pretty simple and pretty easy. But in my conversations with people in the tiny house movement and stuff like that, I've discovered that a lot of people find what I consider to be basic construction and various other things a little difficult, and also solar panels and all of the other things that go into it. We will be covering all of this stuff. So today what we're doing is I'm sitting pretty near my site that I'm going to be using. I've got a bit of noise in the background there. Hopefully this is picking up. So I'm in an urban area in Christchurch. Never you mind where exactly. Using some friends' land, and I'm gonna build this really tiny thing. So what I want to do is sort of just work through what the project is today, and then tomorrow we'll get more into actually doing stuff with it. So as I said, I'm calling it a micro home. So that's a thing to cover. Tiny houses, a lot of people are going to be familiar with these already. You've got your sort of 2.4 by 5 meter thing on a double wheel trailer, or a 2.4 by 7 meter, or a 5 by 7 meter, or whatever else. So tiny homes, where basically we take what you put in a normal house and we make it really small, but it's still got, you know, entertainment space, all these kinds of things. What I'm interested in doing is the next step down or up the track from there, depending on how you look at it, where we look at what is the minimum space that a person can occupy. The nearest thing to sort of my design ethos is I would say the LEM module. I think is the LEM? Yeah, it's the LEM. The lunar lander module that they use for the Apollo missions. How do we keep two dudes alive for 4 days in a ridiculously inhospitable environment? And thus they did the thing and stuff. And the way they slept those dudes and stuff and did all this kind of stuff, it's absolutely terrible. They didn't factor lunar dust. It was very difficult. Really interesting stuff, actually. Look it up on YouTube. Very cool how all that worked out. But I'm very interested in how they use space in space stations, in the space shuttle, in the Russian Soyuz modules, and various things like this. You know, how do we create a livable, functional, working space for a human being where you can sleep, you can eat, you can shit, and you can do basic office work level stuff, a little bit of science maybe or whatever, in the tiniest space possible. Because I think on planet Earth here, inside our atmosphere, this is actually a very useful concept to use. So what I'm approaching is what I call a micro home. It is, I'm going to live in it. And what I'm looking to do is basically a cheap build that requires very little skill to put together, that is simple, that will provide eventually, I'm going to start with just a place that I can sleep and work and doing my artwork and stuff, but we will also eventually look to put a toilet unit and a kitchenette and stuff like that in that, so we can cook and stuff. So it's a cook, sleep, studio and toileting space. You basically keep one human being alive, as small as possible, mobile, without a trailer or anything else. So unlike tiny homes, this will not have wheels. It will be so small that we can just take it apart and put all the flat pack materials on a trailer and move it to a different site and stuff like that. So one of the things we're doing with this design actually is we're going to put it together entirely with screws. And that means that your only tools that you require to make what I've designed and what I'm going to be building is a cutting device, so a rip saw or a skill saw or some sort of, I can cut sheet wood and small bits of wood device, or tool if you wish, and a screwdriver technically, although I would highly recommend, and I will be using a cordless driver, so that I've got, you know, I need to pump about 500 screws to put this thing together. So yeah, I ain't doing that by hand. You could, if you need to, but I ain't doing it by hand. And you need some means to drill pilot holes for the screws and stuff like that. So if you can drill a hole, punch a screw in, and cut wood to basic dimensions, shave a sheet off there or whatever, and do basic measurements and stuff, you will be able to build this thing. So what it is effectively is a garden shed with solar power and a whole bunch of clever crap added to it, but it's basically, structurally speaking, it's a garden shed. And the cool thing with that, the layout we're running with is going to be 2.4 meters long and 1.2 meters wide. Our floor plan. I'm going to be going quite high with that, which will allow me to have a micro mezzanine in there to sleep on and stuff. Like I said, this is for one person, not for lots of people. It's a very, very small space compared to other YouTube videos on things like this. The nearest you're going to come across is living in a van. I'm going to use a lot of very similar technology and idea sets and stuff like that, but we're going to be building this thing from the ground up with no wheels, and it has standing room in it, which vans do not quite often. So, it has some advantages and stuff. So what we're going to do is build a basic box, or garden shed, like I said before, and then we're going to try and, what can we do with this? How many little magical bits of technology and stuff can we add to it? What is it like working in a confined space? I'm going to work through that process. I'm going to blog it every day, tell you all about it, see how we go. Which is going to be really, really fun, because it's it's just started summer here in New Zealand, and it's already baking hot all the time. My God, I'm getting cooked. It's horrendous. I did a few missions today, just walking around town here in Christchurch, the city that I'm going to be doing this process in, to go price up some items and things like that, and it's just too messy. So I'm drinking beers and staying out of the sun. So yeah, I think that outlines our project basically. Think tiny house on wheels, as they call them these days, or THOW. Do we say that acronym that way? I don't know, but it's an acronym, THOW, tiny house on wheels. Same sort of concept structures and stuff like that, but I'm looking to house one person only. And I'm specifically gearing my design structures towards people like me who've already experienced poverty and have very little stuff due to that poverty, which I do. I can walk carrying everything I own in a tramping pack. I'm not saying this is the only kind of person who could do what I'm doing, but you do need to limit your gear down. Obviously, in the floor plan I just described before, 2.4 by 1.2 meters, you're going to have very little space. But what I'm going to get into is how we can use space smart, and what things we really need to own to do our job or whatever else and stuff like that. For instance, you can't entertain guests, but you can add on a little deck with a tarpaulin or a shade sail over top and create an outdoor space that you can have guests in and things like that. Or you can't cook magical roast meals, but you can go to a friend's house and use their oven and cook for them. Or you can go to a restaurant and buy your food. So what I want to look into is how do we downsize as much as possible as a human being, and benefit from that. The benefits being it's much cheaper. The resource requirements in terms of energy and stuff like that, solar power and so forth, are much cheaper. I'm definitely very into using cell phones for computer function and access to the internet and things like that, as opposed to laptop computers. As a good example, a cell phone draws USB power at bugger all watts. Your average laptop computer pulls 240 volts out the wall, gears it down to 18 volts, punches it into the laptop and stuff, and your average laptop draws about 40 watts when it's running peak efficiency, peak power, and running all the things, maximum screen brightness and all that kind of stuff. My entire house design runs on about that much power, because I use LEDs for light. I'm looking at using, I do use the phone I'm filming this on for my main access to the internet and my main usage of technology. It also runs my media, if I want to watch videos, do anything like that, blah, 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 blah. Everything runs on USB. So everything runs on 5 volts. That means that my solar system, for instance, is going to be a lot lower wattage and a lot lower power than you would normally do in a tiny home where you're using a 12 or a 24 volt system, which you're then going to invert upwards to 240 volts, so you can run fridges and all kinds of things that I won't have. And what I'm going to do is work through the process of showing you, the viewer, how to do that. How do we live without a fridge? How do we, maintain our normal life and our access to jobs and education and information and the things we get through the internet, and just life in general? How do we live comfortably on the really, really minimum levels of energy? So yeah, that's pretty much what we're going to be doing today. What I did was I went out, I did a single mission. I meant to do 3 missions, but the first one required me to walk like 6 kilometers or whatever, and in this heat, even that, it was just brutal. And so I went sod it on the other ones. I'm about to hang out with my mate, and we're going to shoot down to the shop that I did go to and price up some furniture that I'm going to be using in this construction, and we're going to go buy some kit set furniture stuff. He has a car, so he's going to help me out there and bring it back to site. And tomorrow I will be doing some more missions. On Wednesday in particular, which is the 3rd day from here, we'll be doing the main buy construction materials missions. A lot of ply, a lot of really thin structural material and stuff like that. And that's the other thing I'm doing with the structure. My primary construction experience is in building model airplanes and things of that order. So I'm very, very adept at building very, very light but still strong, using material science and processes that we don't normally use in houses, but that I think are very applicable and quite useful. At the size I'm working at, you can afford to build lighter and smaller and finer and stuff. And one of the great things about that is it's a freestanding structure. So when I live in New Zealand, we have earthquakes a lot now, and that's a thing you have to look at. And one of the big problems you have with earthquakes is normal housing, whether it's on pylons or on tablet foundations, which are pretty standard here. People use concrete tablet foundations. Your house is coupled to the ground, and there's quite a lot of weight in your roof and various other factors. So when an earthquake happens, physics is not your friend. With my design, actually, what's going to end up occurring in an earthquake, or in the cases of liquefaction, water coming up through the ground due to earthquakes and things of this order, is it's completely freestanding. It just sits on the deck. It'll wobble around and stuff, but it's not coupled to the ground, and that will allow it to survive with much more minimized structure. Allow it to survive much more violent earth shaking, flooding, and various other factors like this, liquefaction, ground shift, and all the rest of it. Most houses, ground shifts, it cracks the tablet foundation, all this horrible crap goes down. With my one, you've dropped an edge, you go, oh shit, that's not level anymore, jack it back up with some stones or whatever else you're going to do there, and now it's level again and you're done. 20-minute job. And this is the advantage of building as light and as small as I'm looking at doing. There are disadvantages, but huge advantages in terms of disaster resistance, rapidity of putting the structure together, and various other factors. Anyway, I've gotten to nearly quarter of an hour already of ranting there, so I'm going to have a cigarette, and you guys have a good one. We'll see you tomorrow with another rant, and hopefully within the next sort of 72 hours or so, some of these rants will include me running around showing you what I've built for the day, but today it's just too hot, team. Just too hot. You guys have a good one.